Hi, this is Sambasiva. Yeah, I've been in industry for last 18 years, mostly working as a backend engineer. Not only backend engineer, big data systems, machine learning part, and used to work for companies like Samsung, Akamai, Amazon. After that, my startup journey started. So part of couple of startups, we're solving interesting problems. But that recurring theme is, yeah, the same backend we had to do again and again. Okay, that's where we thought, okay, let's have one solution for all these problems. Okay, that's where that Godspeed systems genesis is.
So yeah, about Samba, I'll say, I have worked 17 years in the industry, and if, probably if there would be one of the best 50 architects and engineers in the world, geniuses, masters who know things, if there is something they've seen it, then Samba is one of them. He's surely one of the best in the world I've met. And it's really an honor and pleasure to work with him. When he sits around in discussions on talking on technology, I've seen even the big architects, they are amazed in awe of the way he speaks and what he shares with everybody. So yeah, that's about Samba. And about me, so I've also been since 17 years on this journey. Graduated from IIT Kanpur in 2006 in computer science, and that's where Samba was also there around the same time in Kanpur. And then basically over last 17 years, I've worked in, Oracle was my first job. After that, I went into startups, and I've also, worked with enterprises as consultant, and as well then, started on my own journey, registered a company 12 years ago. And since then, I'm working on various products and projects of various kinds, including our own products that we made. So in this journey, like Samba said, there was the same thing that would come again and again with, the same solving the same problems. And therein, I also felt during few years ago that I would like to solve this for myself and all the projects I work on personally. I don't want to do same boring job again and again, and also lose my night sleep many times when things go bad in production. So that's where, Samba and I were already working 5 years ago in another startup in data engineering problem. So that's where we had the occasion to start working together. And since then, I started collecting bits and pieces of abstractions. And Samba and I also joined down the line somewhere in the journey again, once again. And so we are working on solving this problem together. Yeah. All right. So yeah, the topic of today's conversation and sharing is about backend engineering. All about backend engineering. How has it evolved over the years? And we will be simply talking about the approaches, the processes, and the architectures that people have used over the years, and how this whole ecosystem has evolved.
So mostly we will be talking about how backend engineering evolved over the years. So what we used to do in olden days, now what are we doing? So how Godspeed systems trying to accelerate that process of building backends. Yeah, let's
So,
start with so around circa 2000. So the predominantly we were
mhm.
using all big frameworks like .NET or Java, Ruby on Rails or Django. Okay, so that journey started with those big monolith frameworks. When I say monolith, the entire application is built using one framework, and it is one code base. Okay, and the three layers there. One is the presentation layer, or front end or client layer. Second one is the application, and third is the data persistence layer. That's mostly database, relational databases. There was no SQL or new SQL, nothing. Key value stores, document stores. None of them are not there. So only thing is relational databases and all these big frameworks, .NET, Ruby and Rails, Django, or PHP, Symfony, whatever. This type of frameworks there, and we're building using one code base. The entire backend is in one code base. That's what that era is monolith. Okay, but it's a three-tier architecture. Presentation layer or client layer. There is the application persistent, data persistent layer. It's mostly the databases. Okay, so after that, so they're not scaling. Okay, because the number of people accessing these services or applications are increasing exponentially, but these systems are not keeping up, these applications are not scaling up. Then people have their band-aid solutions where they try to scale by adding caching layer in between your application and database or data store, because most of the problem scaling problems are due to their databases generally not designed for scaling internet scaling, right? So this simple business applications, whether it's we are performing simple CRUD operations, okay, all transactions, that's the use case for the predominantly RDMMS or relational databases. They're not keeping up. Then what people are come up with is the scale, to scale that they come up with one layer in between, caching layer, okay. Application try to cache as much as possible. Most of these caching systems like Redis or memcached or ev caches, all these systems are in memory key value stores, okay. You can look like that. So first they'll try to access from the in-memory systems, caching systems. If it is not there, then only they'll go and access from the data store, that is database. Okay, this is what it evolved. That, see, what is the problem? Problem is scaling. Okay,
Hmm.
problem is scaling. Okay, so then they try to come up with different solutions. They introduced a caching
And
layer. Okay,
and
and
also
the
Samba for scaling, typically they would do vertical scaling that time, right? Just increase the RAM and CPU of your instance.
yes, absolutely. So
Hmm.
absolutely the vertical scaling, that is you had to increase the RAM, you had to increase the CPU, a number of cores or all. That's not a scaling. Then they come up with the next, okay, architecture is service oriented architecture. Okay, this monolith or one
Samba,
code.
before we come to that, would you like
Yeah.
to talk of the messaging also? Here in the diagram, there's messaging as well. A little note on that.
Yeah, that is all evolution of the service oriented architecture. So that monolith that tried to divide it into separate pieces. Okay, and some of these services, let's say service. What is service actually? Let's try to understand what is service. Okay,
Hmm.
service has some defined responsibility. Okay, there is a one responsibility. Let's take account service. What is that responsibility of the accounting service or account service? Okay, storing the accounts. Most of the time it's a CRUD operations over account entity, okay, or transactions related to that account, okay. That's what the predominantly the responsibility of the account service. The booking service,
Hmm.
okay. See, if you see, all these services have their own responsibilities and managing their own data. But when service oriented started, most of the time they used to share the data bases. Okay. So and
Yes.
these services also communicating using message buses or Rabbit
Hmm.
MQ, Zero MQ, okay, or some other internal inter-process communication mechanisms. In olden days, we used to use Corba. After that, they evolved to gRPC Thrift. First they started Thrift. It's a Facebook or Twitter. This Thrift. After that, gRPC, some internal RPC mechanism as well as the message bus. That's how they communicate with each other. Okay, to solve whatever the problem they have given. Okay, so but after that, what happened, right? Okay, so yeah, next the evolution the service into oriented architecture is true microservices. Okay, even they try to, okay, divide one service into single responsibility principle, okay, and each microservice has their own data store. Say for example, if it is a transactional in nature, then we'll go with the relational data store. But if it is not transactional, it's like let's say user profile, yeah, better to
Hmm.
store in the document store kind of stuff where there is no structure on it,
Hmm.
because we can keep on adding the fields under. So the evolution from the service oriented architecture to microservices, so that the advantage there is you can choose your own data store according to your data you are managing. Okay, you know what is your data models, okay, how to store them effectively or how to query them, and which data store which will help you. Okay, that is where the microservices architecture, people are saying, okay, you can choose different programming language stack and different frameworks to build the microservices, but that proven from the experience that it's difficult to manage if there are 10 number of tech stacks. Okay,
Yes.
because not the talent, so that not only the developing, right, you had to manage in the production. So operationals also it's a very difficult if you have n number of tech stacks. Okay, so yeah, data store predominantly data store and single responsibility principle, and only 2 3 folks are managing one microservice. And because now towards the shift left architecture, most of the time it's a responsibility of the developers. Okay, not only developing, making it ready for deployment. That is coming up with the Docker files or your Helm charts, or another important piece we'll discuss
Test
that later. Yeah, another
test
important
cases
piece is,
also.
yeah, writing
Hmm.
test cases.
Shift left
uh,
architecture.
and so it's a continuous integration, right? Let's say 2 3 developers are working in. So when you push the code to your Bitbucket or GitHub, then continuously that will compile, build that image, and it will execute bunch of tests, and the push that image to Docker registry or internal registry, whatever registry you have. Okay, that is what a CI is, a continuous integration process there. For that, you need to, in your code base, you should kind of configure that CI flow workflows. Let's say in case of GitHub, it's a GitHub actions. If it is something else, then you had to have that manifest or kind of workflows embedded in the code base also, because it's a responsibility of the developer. Okay, to have those workflows inside a code base for CI part. Okay, next is the deployment part. Now once it is yeah, once we move to Kubernetes and all, now it is Helm charts, Docker files. You need to make the Docker file, Helm charts, all the stuff also should be ready. That is
Hmm.
integration, deployment. But another important piece is, because it's easy to develop a microservice because of single responsibility principle, then you can develop a number of thousands of microservices. Then it's again problem is managing is a problem. Okay, that is where this observability, monitoring and observability is very very important in microservices era. Okay, so that is where the new standards like open telemetry and will help. Okay, it's also responsibility of the developer understanding, okay, what is observability, how to
Hmm.
produce that. There are three pillars of observability. The first is the log, second one is the metrics, third is the traces. First, you developer has to understand what are these three pillars. Okay, how to instrument their code base to produce these three data points: logs,
Correct.
traces, and metrics. Okay, not only that, there
Basically,
is yeah,
hmm. Basically, Samba, let's say if a request comes, right, it goes through 5 microservices and it breaks somewhere in between. So then in modern times with this architecture, we need to know where exactly did it break, or
yeah,
if it is getting slow, in which microservice is it getting slow? If it's a
yeah,
particular database call that is becoming slow, then which is that database call which is getting slow? So in
yeah,
distributed architecture, it becomes difficult to zero in on the problem. What
yeah.
is happening in my system? And that's where observability becomes very important and developers should notice this.
Yeah,
Hmm.
see, if it is a synchronous calls, it's very easy actually. We can trace some using some unique identifier. Okay, across 5 microservices. Just assume that. Okay, asynchronous is also added to the mix. It's not only
Hmm.
synchronous API calls. There is a synchronous way of communicating messages, and that other microservice will respond again by emitting another message. It's like a flow of messages between 10 20 microservices. Just imagine to debug where is the issue, right? If it is a synchronous
Yeah.
call, it's okay, but there is one request ID or one unique request ID, and it is flowing that. But if you add that asynchronous and exchange of messages, then how do you debug that part? Okay, so
Correct. Correct.
that is what we are trying to solve as part of our Godspeed. Okay, we are trying to
Hmm.
unify whether it's asynchronous or asynchronous, okay, into one abstraction. Okay, that is event is what, whether it is an API request is an event, or incoming message is an event. Okay, whenever something entered into your microservice, then your unique identifier is attached. Okay, that's generally called trace ID or span ID. Yeah, most important thing is, it is first not only that HTTP or synchronous request. HTTP request means whether it is a REST call or a gRPC call or GraphQL call. Okay,
Those
message also,
they are
yeah,
mechanisms
message,
basically.
yes.
We
Message
we can call
also,
them mechanisms. Yeah.
yes, message also will have the unique identifier, and that has a
Mm,
context. Message also has a context, and that context also propagated along the path. Let's say one
mm,
message traveled, and again that microservice produced bunch of other messages. Then it has to
mm,
propagate this context, where what is the original context. It's like a tree, right? Okay, one root
mm,
node is there, right? Then after that it's emitting the bunch of messages. That context has to propagate till that end of the messages or whatever. So then it's easy to debug that. Not only synchronous request response model, it is asynchronous events model also, event driven architecture also. We're trying to unify that. Okay, there is an event, that's API request an event. Then if there is already context associated with that event, let's say in case of HTTP request, HTTP headers is attached as a context, like a trace ID or span ID. In case of message also, we adopted, okay, cloud events format, where there is a header and body, there is a metadata. That metadata also has the context. That is what context? That is a request context or whatever, the unique context, so that it's easy to debug that part. That's most important.
mm.
Okay, that is where
Correct.
that event abstraction is. Event is what? You are responding, your microservice is responding to that event. Okay, then generally what microservices will do, just if you see that high level, right, there is an event. Then you will read that event, you will validate that event, right, you had to
Yeah.
validate
Yeah.
that event. After
For
that,
example, that my API contract publishes a certain schema, right? A requirement that there must be an email in this form, there must be a name, and email is compulsory. Email must be of this regular expression. So you mean all those validations of the input, right? You validate
yes,
the input.
yes.
Yes. Mm,
In case of HTTP, it's a
mm,
request body, let's say, or request model,
yeah.
or API
Mm,
model. In case of
mm,
message, it's message model, message structure.
correct.
Why you had
Mm,
to write code for validating? Just imagine, right? Do you need to really write a
mm,
code? Because it's a structured data you're exchanging most of the time. Okay, either through synchronous API calls or asynchronous messages. Okay, the structure we know. That's what. How do you define a structure? In programming language, you'll define structure using classes structures. You will say int and string or whatever data types. But that itself is not enough, right? To capture the business entities. Let's take PAN card. PAN card is a string, but there is a structure to it.
mm,
There's a 10 characters. There are certain numbers
mm,
there, certain characters there. That is not captured in any programming language. You can't express that, you have to write code that. Okay, that is
mm.
where the new age technology like a JSON schema trying to solve this problem declaratively. Okay, that
Schema-driven
is
development, we'll call it, Samba, right?
exactly,
Schema.
exactly. Schema driven development means what? All your
Mm,
data, incoming data, that's event data or event model, whatever called it, API model or message model, message structure, we will free define it. Okay, we will attach the schema, and we'll, so whenever the event is inside a microservice, first thing we will do is we'll validate it. You are not writing in a single line of code. Okay, developer has to only declaratively specify what is the format, what is the model of this event using
mm.
JSON schema. Then everything else is
Mm.
taken care by the framework. That's the first thing. Okay, this is data oriented program. There is a one abstraction, one concept called
And
data oriented
Samba,
program. Yeah.
Samba, another benefit of schema-driven design is that your documentation can be auto-generated from it. Your mock server can be generated from it so that front-end developer can start developing right away while the back-end developer is developing the real
Yes.
implementation. The mock service is up straight away. Then also
Yes.
your test cases, API test cases can be auto-generated based on your schema. So there's so many
Yeah.
benefits of this approach. Hmm.
Documentation, code generation, test suite generation, and mock service
Mock
generation.
server.
All these things can be done if there is a
Yeah.
schema defined. That is, developer has to start with the schema first.
Hmm.
Okay, the first he has to understand what are the various events he will receive or he will respond. Okay, then he has to
And this
define
is what
what
was attempted at GraphQL also, right? In GraphQL also they attempted this, right?
GraphQL also has a structure. So this was started in maybe the RPC kind of mechanism where they try to come up
Hmm.
with a okay some sort of definition languages like a protobuffer or before that some ideals something is there. Okay, they try to define the
Hmm.
structure of the message. The messages is nothing but data structure, right? First you have to define your data structure and what is that field structure, whether it is string or number, and what is the range. Okay, and the bunch of high level validation also we can do using regular expressions or min max. That's what the JSON schema, predominantly JSON schema.
Hmm.
In olden days we used to do XML schema, XSDs and all for
Yeah.
validating XML data, right? So that's the whole point of schema is whether it's XML schema or JSON schema or some other ideas like protobuffer schema or arrow. So there the schema is a metadata about that meta model or a model. Okay, it is conveying something, and so that there are other benefits like we can auto validate. Okay, we can generate the code. Like let's say we are generating code in Java, then you can automatically generate the Pojo classes or
Hmm.
Ruby, whatever those classes we automatically
Hmm.
generate. Those are the advantages of the schema part. Okay, event and schema, that is you are specifying event structure schema. That's the first thing you will do. What are the variants your events in your microservice you are handling, either in or out, and you will define the schema. That is what event is. Okay,
And
once
even
event.
Samba, the when we define the event schema, we could even define the authorization and authentication rules for that event also, right?
Yeah, let me
At
come
the
to
same
that
time.
part. Yeah, okay, I will come to that part. Okay, so let's come to first, let's say event triggered. Then what happens? Just take one simple microservice. Let's say I'm order microservice. Okay, first let's say request for create an order. Okay, that is an
Hmm.
event. Create an order is an event. Okay, then generally what we'll do, you will write a bunch of business logic. Okay, predominantly what this business logic will do, it will create a order, right?
Yeah.
That
Because
is
there
the
is exchange of
abstract.
data between the two. Yeah. Yeah.
Exactly. So
Hmm.
that is the other abstraction we are bringing. That is data source. Okay. Event is your data, input data or output data. Business logic is your workflow, and persistence layer, that's a data store or other microservices. That's a data sources. Okay, then what is this workflows most of the time we'll do? Let's take our depending on our experience, 70 to 80% of the time it's a CRUD operations only. Just create, read, update and delete. 70 to 80% of your microservice is just a CRUD. Remaining 20-30 is a specific business logic. Okay, right? Let's say if
Yeah.
once you define your models, why can't we generate a 70-80% of our code, and 70-80% of logic is already there,
Hmm.
right? You have to write only 20-30% of the custom business logic, right?
Yes. I've
That
worked
is
in
what.
Project Samba where for 3 months a team of 4 engineers sat and simply wrote data access layers, CRUD APIs. That's it. We did not have any business logic, only data access. Validate the incoming request, access the database, get the response, return it to the user.
See that, see
And
that, see
three
that
months.
pattern. See that,
Yeah,
right?
yeah, yeah, yeah,
It's
yeah,
a
yeah.
recurring
This
problem, right?
whole
It's a
thing could
recurring
be
problem.
automated. Exactly.
Yeah,
This is, I felt a waste of time for developers to do this. And then there were bugs also that would come on the way, right? It was a headache
yes, yes,
doing this
yes.
manually. Hmm.
Okay, that is where we are trying to auto generate like lot of things. This is a framework. The genesis of the Godspeed is the developer productivity should be increased by, they had to avoid that 70-80% of the mundane or repetitive tasks. They shouldn't do that. They should be spending only 20-30% for their custom business logic, right?
mm,
So,
mm,
and the abstraction of data source solves lot of problems. Let's take one example. Let's take one example, right? Uh, so most of the time, let's say when we are accessing the microservice, first thing is you need to authenticate with that microservice, get that token or whatever, right? And after that,
mm.
you have to send the token in every request. Okay. After that, whenever token expired, you had to refresh the token, get the token again, and do this.
Mm,
Can't we automate this process? Why? Why
mm.
every time you have to do this for every microservice, you had to solve same problem, right? Authenticate, get the
Yeah,
token, store the token somewhere, to send the token in every request, okay, and refresh the token when something expired or something, right? So this is what
yeah.
it's doing. It's a repetition, right? Unnecessary thing. That's
Mm,
what we are trying to
mm.
solve in systems. You are defining that data source. The data source you can specify, okay, how to get the token, okay, then framework itself will taken care. You no need to worry, okay, how to refresh the token or how to send the token in every request. Nothing. Okay, if it is standard compliant OIDCNL, you no need to even specify how to get the token. Framework automatically figures how to get the token. You have to just specify what is the OIDC server, your identity server or whatever. Okay, that's it.
Mm, mm, mm.
So that's what. So if you see that high level, right, we are repeatedly doing the same thing. There is a request, we'll go to the database, get the data, and do the simple transformations, not even complex. In microservices, I don't see people doing complex business logic, ton of computations and all. Okay, that generally they'll avoid and move it to some other parts, some big data frameworks or something. Okay, if there is a heavy computational involved in that, microservices, they'll do simple transformations. And not only that, they'll aggregate from different data sources. So that's another important thing is data source. If it is a data store or an API, both of them are, we can treat it as same. So as a data source, then what are the advantages? You can aggregate across the data sources. You can aggregate the data across the data sources. You can join the data across the data sources. Okay, you can orchestrate across these data sources. That is what your workflow is. Okay, simple.
Samba,
It's not.
could you
Yeah.
explain orchestration? Maybe all the viewers don't understand this.
Yes, sure. Okay. So let's try to understand. Let's say there is one request. Okay.
Mm,
And I need to talk to 5 other microservices, get the data. At the same time, I need to talk to my database. Let's take an example. Loan application. Okay. I have 5 partners,
mm,
5 loan providers I have.
mm,
Okay. And I have my own database. Okay.
mm,
Should I send a request to the all 5 partners one by one? Or should I send all of them and we will wait for the response, something like, right? We shouldn't be
mm,
sending one
mm,
by one, right? All these 5 requests
mm,
should go in parallel, right?
yeah,
All these 5 requests should go in parallel. Okay, get their response. Depending on the response, you do some transformation, some process. You join that, okay, and take some
mm,
decision and you store in your data store,
mm.
right? You'll store that in data store,
Correct,
or you will read something from your data store, join with all the 5 pieces, and send that response back to your client,
correct, correct. Mm,
right? So that's what
yes,
you're doing. So we need to understand what is the computation model of your microservices. This is what you'll do
mm.
from the data
Yes,
sources.
yes. So basically, in the end, when we execute a business logic in the computation, most of the times we are accessing multiple data sources. Either it's
Yes,
data stores or APIs. We are combining response, we are transforming the response, and then we are returning the response. That's what we
that's
do.
it. That's what you do.
That's it.
That's it, right? Okay.
Mm,
So but there are some
mm,
cross-cutting concerns also, right? That is the core of it. But what are the
mm,
cross-cutting concerns like? Okay, other let's take not only the accessing the data sources, right? We need to authorize. Authentication and authorization is very fundamental piece for the modern age microservices, right? In zero trust
mm,
architecture, every microservice has to validate every call. Okay,
mm,
every call, right? That's what
mm,
authentication and authorization. So, but if you see that at the high level, you can declaratively express those authentication and authorization. Okay, you don't need to solve that again and again. There is a
mm,
specific to that. The policies are specific to the microservice, but
mm,
not code.
mm,
The
mm,
policies are, that's okay. There are two types of computational model in authentication and authorization system. Let's take two different services: authentication service and authorization microservice. Authentication service is mostly imperative model, right? So the authentication service stores something related to user, and user has to prove that he is that guy. That's what authentication service is. Mostly it's a lookup or do simple strong
mm,
computation and verify that computation, blah blah blah, and it'll send that response back. That is what
mm,
authentication service. Authorization service, that's not imperative. That's a logic programming model. That's an expert system. That's a decision making system. That's a different type of computation you had to express. Computational model, right? There
mm,
are thousands of rules. You need to execute thousands of rules one by one, right? That's what
mm,
business
mm,
systems, rule driven systems, or policy driven systems, all of them you can execute in any fashion, whatever fashion you want. That is what these systems are. Logic based program prologues and kind of the systems. Okay, that kind of computation can be easily expressed using those type of programming languages. So then authorizations, what does authorization systems generally do? Authorization systems, right? It's a decision whether this guy is allowed to perform this operation or not. Very simple. What is operation? How do you define what is operation? Again, resource or data source, let's say, right? Resource is meant what? It could be table, it could be some other function in your code. That's called a resource. But what is an operation? I read or write or delete. Most of the time it's CRUD operations, right? Most of the time,
mm,
right? Or execute.
mm,
You can execute that
mm.
function when it is a resource
Right.
is a function. When you, that's what, that depending on the what is resource or depending on uh, your this requirement. But this is what
Mm.
there is a user or actor, and there is a resource. That resource could be anything. It could be database, it could be table, it is a function, it is a class, or could
Or
be
an
object,
image.
anything. Anything,
Uh,
anything. Okay, that is a
yeah.
resource.
Yeah.
And what is that operation?
Mm,
It's a read, write, delete, execute. Okay, these are the operations.
mm,
But then what the authorization systems will say? Okay, whether this guy is allowed or not, true or false, most of the time. Okay, but sometimes they'll return bunch of the statements also. Okay, so that you will take it and you'll send that as part of your query to a database to filter out in database itself. Instead of filtering it the application layer, you have to filter in the database layer also, depending on the user permissions, user role, or depending on
mm,
the user. Okay, you have to filter out that in case of multi-tenant data stores and all, right? You have to, or depending, not even multi-tenant data store, even in the within the same tenant also there could be different users, right? Different roles. Some are editor,
like an
some reader, some,
admin, a super
yeah,
user, editor, reader.
exactly.
Yeah.
Depending on that,
Mm,
you have to filter out some rows in the table.
mm,
That,
mm,
how to filter out that and all, that the authorization system can emit that. Instead of writing, you shouldn't write code. Okay, you should write the policies. The policy should express that. Okay, whenever this guy want to access this table or this resource, you have to filter out these rows, because this guy doesn't have
mm,
access to,
mm,
and these columns also, these rows and these
mm,
columns,
mm,
this guy doesn't have access. That is, you have to express declaratively. See, the idea
mhm,
behind these Godspeed systems, right? Instead of how to solve the problem, or how to developer has to focus on what they want to achieve. Okay, what they want to solve. Okay, that is declaratively. That's a fourth gen language like SQL, and declaratively they had tell us. Then the framework will figure out how to convert this into that instructions, logics, or whatever. Okay.
mm, mm. Yes.
So it's high level. These are the three abstractions, and we're trying to use schema driven, standards driven. That is, we are trying to adopt cloud events format and all.
Mm,
And abstractions like data source, trying to unify a data source with the other microservices or third party APIs. Okay, and workflow engine. Workflow engine has to
Hmm.
try to automate 70-80% of your repetitive task. Okay,
Hmm. Hmm.
and declaratively have to
Correct.
specify this resource or authorization policies also. You can attach to
Hmm.
your workflow all your authorization in decisions. Okay, so authentication also you can do that declaratively, authorization you do declaratively, and caching layer. Let's, for example, there is a caching thing also, right? Why they had to write code to access this cache and all? They had to declarate it, tell this is the resource I want to cache it. Okay, and this is I want to
Correct.
invalidate if something happened, something like this. Are all declaratively they had to express this, right, as part of their business or workflows, business logic or workflows. Okay, let's
Correct.
take one another example. Dual write is very, very,
Hmm.
very common problem. What is dual write? You had to write to the
Hmm.
database, at the same time you had to send to the Kafka also. Okay, but these two are independent systems, and it can't be atomic operation, right? One can for
Hmm.
successful, another can fail, right? You
Hmm.
can write to the database at the same time, but if you want to write Kafka may not be available, then it may fail.
Hmm.
But how do you make sure that so it is writing to the database at the same time it can write to the Kafka also? That generally called dual write problem. Okay,
Hmm. Hmm.
dual write problem, but this is a common problem, right? Why developer has to solve again and again? Okay, the framework should solve it, and they has to declaratively say, okay, I want to write to these two data sources. That's it.
Hmm.
Framework
Hmm.
will figure out how
Hmm.
to write it in an atomic way. That's it. You don't need to solve by yourself.
Hmm.
Okay, you are saying this is my piece of data and these are the data sources. I want to write to these data sources atomically. That's it.
Hmm.
Then
Hmm.
framework will figure out like that.
Correct.
See, we're trying to abstract out and solve a lot of problems, repetitive problems for the developers, so that they no need to reinvent the wheel again and again. That's the idea
Hmm.
behind this.
Exactly. And the big companies of the world like Google, Facebook, LinkedIn, they have their internal frameworks. But for every other company of the world, all these startups and even many enterprise companies, we don't even have the time to build such frameworks. So you just start go and coding all these things together, and in the process, over the years, you start building some frameworks also. But then the problem is that the developers who build the framework then keep going, and new people also come. Then maintenance becomes a problem. So effectively, only the best of the high tech companies in the world enjoy such frameworks within themselves. And so far, I am personally not aware of any framework which solves this problem holistically. And I guess Samba is also not seen this. So that's why two of us are sitting here along with our team to solve it. And, an end to end solution of the full process of backend engineering from your coding to testing, documentation, CI CD, security, scaling, observability, all of this could come in one place with one framework, which makes it very easy for us. Just sort of declare things and let the framework handle it for you. Yeah.
Developer should start with the Ubuntu systems or Linux basis or Unix based systems. Okay, they shouldn't
Hmm.
start career with the Windows. Okay, that is
Correct. Yes.
that is the biggest thing I think the decision developer has to make. Okay,
Hmm.
so you start coding using Unix based systems, either it's Linux, Ubuntu, or Macintosh, doesn't matter. Okay, so I saw people started career with Windows. Uh, but problem is most of our backend microservices runs in Unix based systems. Then you should know what is top command, at least the basic. What is file system? What is Unix based file system? The structure. There are things you have to know, because as a developer, as a backend developer, everything is revolve around Unix based systems. You should know about Unix based systems, and you should start using Unix based system for your development, day to day activities.
Hmm.
Yeah, definitely should be familiar with microservices architecture. What is microservice? Okay, then they had to know. okay, how to develop microservices. There are frameworks or whatever, the languages. Okay, that's the secondary thing. First is high level microservice definition. Okay, what is bounded context, what is
And
deployable unit. Okay, and another very very important nowadays is you need to know about Docker and Kubernetes. Without that, I think there is no world. Okay, say you have to know about Docker, you have to know about the containers and orchestration. Whether it's a Kubernetes or tomorrow some other tool, doesn't matter. Containers and container orchestration, you had to know about that part.
mm,
Okay, so this there are some fundamentals concepts every backend developer should be familiar with. Okay.
yeah, like somebody standards and best practices are there. So every developer should know that. For example, what is Open API schema standard?
Yeah.
What is JSON schema? Right? Then
Yes.
what is REST? What is gRPC? What is GraphQL? And what is federation, data federation, orchestration, authorization? These things every developer should know.
Authentication,
And
authorization. Yes.
authenticate. Yes.
So definitely, I will suggest the four different skill set for any programmer or software engineer. The first and foremost is the problem solving skill. Okay. Second one is the domain expertise. Okay, when I say domain experts, all this comes under Unix, databases, microservices, web server, front end engineering, some blah blah. That's domain expertise. Third is a programming skill. You have to be, let's say, not only knowing the syntax. Okay, you had to know in and out of every programming. Like you had to know what is stack based language, what is a heap, what is a garbage collection, what is a reference type, value type. You had to know bunch of concepts. That's a programming skill. Fourth important skill is a testing skill. Okay, so it's not
Hmm.
only writing code, you need to think from as a tester. Okay, and you have to write bunch of test cases. Okay, so that's what these four different skills. Okay, problem solving.
And to that, Samba, I'll add one more thing is, how to debug errors. So I've seen that young developers, when they see an error has come, they just panic and there's an error log right in front of them telling what is the issue, but they are scared to read the error logs. So it is very important how to, find out what's a problem and then solving the problem and not to be scared of errors. It is all right, they come. So, and yeah, yeah. So, yeah, how to debug issues in your system.